Hello and welcome to today's webinar. I'm going to introduce to you today the new Metrology 4.0 software platform. My name is Greg Roper. I'm the product manager for the surface finish instrument range at Talylor Hobson. I'm going to run a very quick video which will introduce the physical instrument and show that with the software and how it interacts. Then what we'll do is we'll return back to an offline version of the software where I will go into some of those aspects in a little bit more detail. So let's switch over to the instrument view and I will press play on the video.
My name is Greg Roper. I am the product manager for Talylor Hobson's surface finish instruments. Today I'm going to give you a general overview of the PGI Novus. This is our flagship surface, form and contour instrument, and then I'm going to focus a little bit more on the newly released Metrology 4 software. PGI Novus is the world leading profilometer and offers the lowest noise floor system on the market. They come with two anti-vibration mounts, passive and active. This one here being the active vibration model. The instrument boasts the largest calibrated gauge range and is available in single bias, where we measure in the lower direction, and in dual bias, where we measure upside down. This gives us the capability of quantifying part diameter. This particular system is a dual bias system with a 200mm Travis unit, 700mm high precision column, and we currently have it with the instrument surround and the Y stage capability for measuring 3D. The software is split into three main areas. They are the instrument view for control, for movement, for calibration, and also programming. The analysis view, where we can analyze for contour, for 2D, and for 3D. This can also consist of numerous documents on the screen and multiple page documents. And finally, the production interface, where we can apply automation, simplify the control, and automatically output the data for statistical analysis. This example, where we're showing here, is for the measurement of multiple parts at different sites. The software works better with multiple screens. This allows the user to customize the view and to start to move areas of the software around the system. This makes it easier to see and easier to operate. These can also be recorded and saved as multiple layouts. And by clicking areas of the software, I can redistribute the software into the recorded format. For example, if I was recording a program, I could put it into programming mode and display the programming window. And in this example, emphasis on the gauge icon as well. Moving back to the instrument view, we can see the software is split into distinct areas. The instrument ribbon at the top of the screen, which is then split into positioning, gauge, calibration, the instrument view and zoom area, programming, and any macro buttons. The measurement toolbar is on the left. This one includes 2D X measurement, automatic measurement, discontinuous measurement, and also 3D. And on the right hand side is the instrument control. We can also pin any of these windows and resize them however we want the instrument to look. And in the middle of the screen, you'll be able to see the virtual instrument. This is a real-time measurement. So any measurements that we take will appear in this view here and will also appear where the part is actually physically being measured. If I move the instrument using the joystick, you'll be able to see that the physical instrument will move and also the virtual instrument. On the Y stage we have at the moment is a 3D model of the artifacts that are currently physically on the instrument. The Form Talysurf system now has a coordinate system, and I know exactly where the stylus tip position is. On the palette shown, we have moved the coordinates to a reference ball that's actually on the fixture, and therefore I know exactly where the fixture is in relation to the stylus tip. When we load other PCS points into the system, you'll see now I have the 5 positions of where we start the measurements using the palette interface. We can then click onto any of the PCS points and view the stylus path of which the instrument will take when I select to move to this point. This is called Smart Move, and you can see that when I highlight over the PCS point, it will show that stylus path. If I click on it, it will then move to that point exactly, and we'll be able to see that physically on the instrument and on the virtual instrument as well. At this point, I am now looking at purely the virtual system and the virtual instrument, and not actually looking at the physical instrument.
Okay, so I was actually running that that video through the software itself. So that's one of the nice features of the software that allows us to actually show some instructions to the operator to help them walk through a measurement or other things, and we'll be covering things like that in future webinars. So this is the virtual system. This is the instrument view that you've just seen in the video itself, and this is the PGI Novus that we have as the virtual system. This one's configured as a 120 Travis unit on this particular example. Some of the video didn't actually show where the icon is of the cursor. So again, just to go over the kind of layout that we have here, this is the positional side of the ribbon, the control ribbon that we have on the instrument, where I can complete contacts and I can, bring up the controls. Next is the gauge part of the ribbon, where we have the calibration and the stylus settings. This is the view and the zoom of the instrument, which we'll be using throughout this demonstration. Have access to the programming function, and again, programming will become a future webinar. And these are macro buttons which help me demonstrate the software in a very simple way, but basically means that any end user is able to set their own macros and their own measurements that they wish to complete themselves. So not using the control of the software that's down the left-hand side here. This is the measurement toolbar where you can see all of the measurements. And down the right-hand side, we have configured the instrument control window that you also saw. So at the bottom of the left-hand side of the screen, you'll see the tabs for the instrument analysis and production interface. If I click on the analysis window, you can obviously see the same layouts that we saw in the video. And again, it's important to let you know that we can analyze the contour profiles, 2D surface, 3D surface. They can be in exactly the same document. We're in exactly the same software, and we can have that over multiple pages as well as individual and multiple documents that we're showing on the screen at the moment. The production interface is the last one on the tabs down here, and again this is showing a similar layout to what we were looking at on the video, which is the palette part interface, where we are analysing numerous different parts and seeing the pass-fail criteria and using this to export to CSV or QDAS and anything that we feel we want to export to. We can put these results, text results, into networks and basically allow statistical analysis and traceability throughout our measurement and analysis process. So I'm going to return back to the instrument view, because one of the things that we didn't show in the actual video was a very basic measurement. So this is exactly what we're going to do at this particular point. So I'm going to go into just a simple 2DX measurement, remembering there are other measurement tabs here. We have an auto measurement, an interrupted surface measurement called discontinuous measurement, and also if we have a 3D stage or a Y stage, then we can obviously measure 3D. But I'm going to go for a simple 2D measurement, and let's call this surface 1, and let's just change this back. So I'm going to ask for any measurement length, but one of the things that I would like to show at this point, because I've opened this 2D window, we've basically got some additional things happening around the stylus tip. So using this zoom function at the top of the screen, I've zoomed into the stylus, and you can see these kind of shapes, these curved shapes. These represent the measurement range, and what we'll do is I'll just lift the lift lower so that the stylus is in its middle of its range. So you can see now the vertical range that I have, and it's obviously in a curve because of the arcuate motion of the stylus. And you can also see the measurement length, and that's depicted by what we have here. Now I can type a measurement length in. If I type in, well, let's type in 20, and you'll see that red bar start to move out. Let's change it again. Let's put in 30. Now, if I put in too much, let's say I put 100 in, you'll notice that this bar or this area of the software immediately goes red, and it's telling me that there is an error of some description. At the bottom, it's basically saying that the length that I've entered, the value must be less than 55.9 mil, and that's because the X position is at 64.7. Okay, if I ask for 100 mil, what it will do, it will try and measure, but it would automatically hit the end stop because it's a 120 millimeter traverse. So the software is actually checking, and it does this in numerous different areas. It's checking what you're asking it to do, seeing if it can actually perform what you're asking it, and if it can't, it's letting you know. So it's not going to allow me to actually finish this measurement or start it even, because it's already telling me that I can't complete what I've asked it to do. So let's type in a 10 millimeter length, and I'm going to just pass this information directly to the analysis. This is what this button here for is to display the analysis tab. And I'm not going to worry about the analysis mode at the moment. I'll come to that in 1 minute. I'm going to press OK. And you can see the measurement that was completed between those two kind of gauge alignment lines we have there. So let's just move this back to where it was and set it up as we would normally view it, and I'll come to these in 1 moment. So here is the measurement that we've just taken. Okay, 10 millimeter measurement length, surface 1 is the name, and I'm going to just do a very quick analysis. So I'm going to do a quick extraction. So I'm going to extract an area. Notice that the profile automatically comes up underneath, and this window that you can see on the original raw data, if I move this window and make it smaller, you'll see the zoomed view here, the extracted view, obviously updates immediately afterwards. Okay, I'm just showing you this just for a start of some of the interaction that we can see within the software. So this is the surface that I'm now wanting to analyze. I'm simply going to go to Studies and Parameters, click on Parameters, and we're going to assign some parameters to this particular profile. Down here is the configuration, or the ISO standard that I'm wanting to calculate the parameters again. So I'm going to select 21920. This is the latest 2020 parameter set, which is included in the software already. And let's just click on a few of those parameters. We'll have some leveling, some form options on that surface. And again, we can change the filters here. Let's change it to a shorter cutoff. And we're actually going to manage the end effects, which means the whole profile is basically what I'm going to actually analyze over. So I'm going to press OK, and immediately the result comes up, and it's put it onto the second page where it can fit. Okay, so what I'm going to do is let's drag this up to the top of the page here, and what we'll do is we'll remove that zoom view from there, and we'll move this up to the top there. Okay. The reason I've done that is because one of the things that I'd like you to see is that this is now the analysis, but it's still connected to the extraction tool. So if I move this slightly, you'll see this update, but also the parameters will also update. If I move this to a different position, graph will update, parameters will update. So you've got a workflow, and this is exactly what this is. This is a workflow of the surface and what we've done to that surface to get to the parameters table. So if I change anything in that workflow, it all flushes through and updates on the actual document itself. So I've created a document. I've got an extra page in there, so let's just delete that page out. Very basic surface analysis there, but what I'm going to do now is I'm going to save that document. Now I can save that as a PDF, okay, and we can then obviously send this through to any of the anybody who doesn't have an offline version of the software. We can obviously send them the results, but I'm actually going to send this or save this as a mounted document, and let's call this the master. I'll save that, and notice that as soon as I've saved it, the master or the name master appears in the name function up here. I want to close that down. Let's close those two down as well. I'm going to leave that one open just for the time being. So I'm going to go back to the instrument. You can see there's the measurement that we've just currently taken. Okay, let's move back and actually look at the auto scale of the instrument. And this is the front view of the instrument. So what I'm going to do this time is I'm going to switch on the TV view. Okay, and this TV view is a larger view and will actually show us the progress of the measurement as it takes place. So I'm going to clear the data and start afresh. So there's no data in here at the moment, and go back to the X measurement. And let's call this surface 2. And I'm going to do again an immediate measurement. Let's put a little bit longer, 15 millimeters. This time I'm going to apply a template, okay, and I'm going to create this in a new document. So I'm going to browse to where I've just stored that particular template, and there it is, called master. Okay, so what this is now going to do is going to measure and analyze with the template that I've just produced. So this time, when I press OK, what you'll start to see is the result appear in the TV view, and you should see an update of that. Okay, so there it is, and here comes the document, and notice the analysis has already taken place, okay, into a new untitled document, but you can see surface 2 in the measurement name and the results that we've got down here, and it's remembered the setting of this extraction area. So again, if I move this, you'll see the graph will update, and so will the parameters as well. Okay, so we've done very, very quickly the creation and saving and the applying of a document. Now, there are some occasions when we would want to have multiple pages of these open. So let's just do that one more time. This time back into here, and let's complete another measurement. And again, what this will do is create another surface measurement that will pass over to the analysis view. Now I've got two documents, 2 and 3. These are what we've just measured and analysed, and what I'm going to do here is just grab this document, let it go, create a new vertical group and show those results side by side. Okay, so let's switch them back to a standard view for the page. But you can obviously see that I've got the ability, in fact let's just increase that slightly so we can see it a little bit easier. So you can now see that I can do some visualizations between two documents. These may be two different parts that we've physically measured here, and I wanted to visually see what the differences were. Let's move the analysis all the way out to the full view, and you can start to then be able to appreciate the differences between these two profiles and these two parts. So it gives you a very good visualization of different parts and be able to do some comparisons with the data that you see on the screen. So again, what I'm going to do is just close this one down, and let's put this back to the previous group. Okay, so we're concentrating on that. Now, one of the things that we can do, and let's get this into a view of the screen so you can physically see what's going on. So we said about the result manager and the workflow. So this is the workflow. Let's just pin that to the side there and just show you some more interaction on the actual surface itself. You can see here, I can actually click into the surface and zoom in, okay, and I can start to move it across and start to look at some of the peak to valleys that we've got in there. I can always click that little icon in the top left-hand corner to set it back to a standard view. Same on any analysis, I can zoom in, start to look at some additional features. If I end up looking, getting to look at something that I don't want to see, then I could just click the icon and move back. This applies to the 3D views as well. So here's a 3D view. If I click it in, I can obviously move this about. I can zoom around. This one has an extraction bar on it. So as I move this extraction, you should see this surface here, which is the extracted area, move as well. So if I move this down, you should see that screen update. So everything kind of flushes through the workflow once we make any changes. Actually, one of the useful things on this particular one, you can see this workflow is a little bit more detailed. This is over 3 pages that we have here. But if you specifically want to get to a particular position in the document, so maybe I want to look at the parameters table for the extracted area for surface down here. If I just double click on it, it will instantly take me to that analysis. Okay, and if I wanted to come back up to this top level here and look at the different views that we have in the document, again, let's go for that one and double click, and it will take me to that tab immediately. So using the workflow is also a quicker way to move around the software analysis pages that we have, especially if we're running over numerous pages there. So one of the things that we can also do is a lot of desktop publishing. And if I go to the edit, we have the ability to put on screen notes, bubbles, text box. We can link, we can put little icons on there. If you want to draw people's attention to, I don't know, let's say the parameters, let's grab this down there and say that these are the important parameters that we've got on this particular document. These will all be saved, these will all be printed if that's what you want. One of the nice features that is in this software currently at the moment is the ability to add action buttons and hyperlinks. I'm going to put a button in, and I'm going to call this show specification. Maybe I've produced this this surface analysis here with against a particular specification that me as a user would want more information about, and so I'm going to actually add a link. I'm going to open this file. Well, that's not the actual link that I want, so bear with me while I go and copy the actual link which I prepared earlier. So here we go. Here's the link to a PDF. I'm going to press OK. So now I have this analysis document. I can save this as well. This will get saved into the actual template. But if I'm looking at this information, these parameters, and maybe I want to see the spec of how we're supposed to analyse it, I can actually click on here, and what it will do is open up the document that actually gives me the result. Now, what I'll have to do is, you can't see that at the moment because I only have one screen showing, so I'm going to just go back and share the full screen. So let's go here. You should be able to see my full screen again. So what I'll do is I'll just repeat that process so that you can physically see it. And let's close that specification down. Again, if I click on the show specification, instantly the document will open, and now I can see that specification. Now all I've opened is the instrument specification for the PGI Novus, but like I said, this could be the specification that you're actually analysing the surface parameters against. So these interactive buttons can be positioned anywhere. I actually have them on the step height standard here, or the step height analysis. If I just move down slightly, what you should be able to see is that's multiple documents in this particular one, but I've actually got a little button here that takes me to the next page, and takes me to the next page, and then returns me to the previous page, and returns me to the previous page. Okay, so there are different things you can do with these interactive buttons that we can put onto the software as well. Right, let me return back to the instrument view, and I'm going to clear the data, and let's switch off the high TV. So what you're looking at the moment is the instrument, the virtual instrument, and we are currently in the front view, and we're currently auto scaled on the instrument. So remember, anything that happens here with this instrument would be appearing on the physical instrument. So you would be able to see the column and the arm move as per the video that we showed you earlier. What I'm going to do is just, we spoke in the video about the coordinate system, and this is just to reiterate that all the Form Talysurf series will have a coordinate system associated with them. So in this front view, you can see there's a 0 position. Okay, the 0 position actually relates to the 0 position of the Travis unit, and realizing that I'm at 105 at the moment. So what we'll do is let's position that to 0, and I'll position the Y to 0, so it doesn't matter. I'm going to use what we call an all-axis move, and move those all at once. So let's, okay, so I've hit the end stop button. Let's clear that. Right. So what we've got now is the 0 position here, in line with the 0 position of the stylus and the Travis unit, and 0 is also relating to the top of the granite. If I go to the end view, again, what I'll do is I'll just zoom in slightly. Okay, all these views are used in different positions or for different applications, but again, you can see 0 is at the top of the granite, and 0 is nicely in line with the gauge. And if I go to the top view, again, not much to see at this particular view. It does have its uses depending on what you're trying to gain access to, but again, 0 nicely in line with the stylus and down the T-slot that we have here at the moment. And then obviously we have the 3D view. Okay, so 3D view, I can actually manipulate this view to any angle that I want, and start to be able to view things that the naked eye can't see. So sometimes, like we say, we can zoom into the stylus tip, and we can start to see some of the surface that we've measured when we have a measurement on the screen. So what I'm going to do is just go to the end here, to this end face view. And what I'm going to do is actually create a PCS point. So this PCS point, let's call it PCS point 1. And actually what we'll do is we'll set 0, 0. So you can now see I've got the arrows on here saying that this is set to 0, 0. Let's go back to the 3D view, and there again you can see that that point. So at this point I've created, now this could have been a feedback from the measurement, could have been an edge detection, something like that. Let's just pin those controls, let's move this column up, and then this will give you the example of what we can physically do with this point. So if I hold on to or hover over this point here, I can actually start to offer different views of how I can move. All right, so you can see on the screen that it's starting to change the or show the flight path of the actual stylus tip. This is what we were calling smart movement, which you saw on the video. So again, if I hover over there, you can see that flight path is a nice straight line. I can do things where I could move, I could move Y then X, okay, move the Z then X. You've got different options that you want to do. Because I'm in this 3D view, I can actually move wholly X, Y and Z and put that stylus tip and that point right together very, very accurately and start to move around the software more accurately and be able to take measurements in a more accurate position. So you saw in the video that we were actually loading against a model, and those points can be related to positions on that model. But I know exactly where that stylus tip is, I know exactly where that physical measurement is. And so now I know exactly where everything is. I can start to just use the visual instrument, the virtual instrument, and I will stop looking at the actual physical instrument. So again, I can go in here and let's create a surface 3. Instead of a start position being immediate, I can actually call it now and start measuring from a point. There's point 1, which we actually is what we've created. Okay, and that point 1 is 0, 0, 0. And let's just do length. I'm not going to apply any template at this point. Okay, so let's OK that. So the measurement takes place at that point. Okay, here's the profile. Okay, and you can see that actually because the Travis unit was physically at 0, you'll see this this profile starts at 0. And again, if we did or pass this into the contour analysis, again you can see, let's just close that down, that it starts at 0, which is exactly where I've asked it to, and that point exactly relates to this point that we have in space here. So coordinates are passed to and from the analysis side and into the instrument view as well. So that's a very quick and a very general view of the software platform, Metrology 4.0. We've seen quite a few things. We've been taking measurements, we've been passing those over to the analysis side, we've been creating our own templates, we've been doing some interactiveness with some of those templates as well. So I'm going to end the webinar with a further example of where we start to use these PCS points and start to use knowledge of a part. And I'm going to use these macro buttons like we explained earlier. These macro buttons can be set by end users. They're not set by Taylor Hobson. You have full control over these macro buttons. I've set them up to take measurements or to do some examples of parameterized programming, but this example, I'm just going to show you a video. Okay, so let's continue with this. Choose the right language. I'm going to just turn the volume down here so you can't see it, but this is a very good example of measuring a roller bearing. This is a small roller bearing. It's about 12 millimeters, 10 millimeters square. And I'm just going to pause it at this point. So what I've done is we've held the part somewhere in the coordinate system, but currently I don't know where it is. So this initial measurement over the top of the edge is to work out where this part is in relation to the style tip and in the coordinate system. So what we'll do is pass it to the analysis side. I'll just pause it again, and we've created and found point A as an intersect. Okay. Once I know where point A is, once I know exactly where this crest position is of this part, because I know what part I'm measuring, I can actually bring in other build points, okay, other points on this analysis, and I can pass those points back to the instrument, which now appear as PCS points. Now I'm using those PCS points to take the measurement. So we're actually using Smart Move here again to move to the start position. And you can see I'm right on the edge, and I'm measuring up the side, and then I'll go over the top and down the front face of this particular part. Like we said in the video, Novus is a dual bias system where we can measure internal or lower surface and upper surfaces in to do part diameter and things like that. This one is measuring this roller bearing all the way around. So again, Smart Move in reverse bias mode, move into the start position, transfer to the analysis side. This is where we have DXF comparisons, and I'll just pause it there. We're looking at some profile analyses, waviness parameters, roughness parameters, which can also be shown inside the contour result, and here is the actual part diameter of that particular bearing as well. So a very nice video that just encompasses some of the things that we've shown you today, which is use of the coordinate system, creating points, knowing where those points are in my coordinate system, using Smart Move to move towards it, and then completing the analyses. Okay, so I think that comes to the end of the what I wanted to show you physically on the instrument. We'll return back to my view, and we'll open up to any questions.
Okay, so we've had a couple of questions come in. I'll just go over those very quickly now. I've had one question that which decision rule is used for any pass-fail criteria in the analyses. So there are tolerances that we can apply inside the software. They can be based on a banded tolerance from a nominal value. They can also be offset tolerances. There are different standards out there offering, different way to examine tolerances within a profile for parameters or for contour, for example. There are also other tolerances that are based on other parameters. So what you'll find in the next few weeks, keep an eye out for some further invites for some webinars, and we'll start to look into parameterized programming, where we can actually use a result from a specific parameter, which will then have an impact on a different parameter, which will obviously then change the way that those tolerances are applied. And that question then goes into further, it goes into uncertainties. So I'll cover that separately, because measurement uncertainty is a bigger question overall. So I'll answer that separately in one moment. I have another question here that says, how many parts can be set up in the production interface? Well, what I'm going to do is just see if I can find my software, and okay, so you should be able to see that software now. I'm just going to move it across so that I can see a bigger version of it. Okay, so right, question over the production interface. Let's see if we can get there. Right, so what we're showing on the screen at the moment is 5 different sites, and that related to what you saw in the video as well. So what we've got there is, in effect, the ability to add as many sites as we want to, but it's wholly dependent on the size of the stages that you're trying to put it on, and the size of the parts, obviously. If I return back to the instrument view, you can see on this particular example, we have, let's just cancel that out. I have a Y stage on here. This is a 100mm Y stage. We offer different sizes on there, so you know we can go up to 200 or 300mm depending on the size of the base. So obviously with a 200mm Y stage, for example, you can fit a lot more parts, either in line or in rows. So you're kind of the only limitation that you have, no limitation inside the actual production interface itself. You can program this up for as many sites as you want to. It's just wholly dependent on the size of the parts and where they're actually going to be positioned. There are other things that we can do here as well. Let me just see if I can bring up the configurator. Just bear with me. Okay. Right, I'm struggling to bring up my rotary device on there, but we have a rotary device that we can fit on the top of there, so you can actually start to analyze those in a rotary fashion and be able to move the parts in a spoke wheel type of approach and move them around the part in line with the stylus to take measurements as well. So the limitation there is purely how you're going to hold the parts and the size. I've got one more question that relates to different stored data. Okay, so I've got one end user here who has already a Talylor Hobson instrument and would want to analyze old data. You're right in effect that if I look at the analysis tool here, and let me just bring in a profile so that we can see something on the screen. Okay, let's just close these views down. So yeah, that is a profile. Metrology 4 software has a different file format. It's just a standard text file format that we're using in the Metrology 4.0 software. This is just to make it easier for transferring of data to other third-party software, if that's what you want to do. It is just a text file, so it's very easily read in other software packages. So this means it's a slightly different one to the previous version, and any old data, which would have been a .prf file, is still compatible. So I can still bring in any PRF formats into this and then analyze them inside the package. So any old data, no problem, we can bring it in. It's important to say that if you're comparing this against an old ultra-based system, then the old ultra-based system does have a database, and that tends to be your kind of limitation, if you like, on those instruments. This has no database with it at all, and therefore the only limitation for size of storage and data is your hard drive, or indeed any kind of network drives that you're using to store the data as well. This is obviously a package that interacts with any network that you have in your site as well. I had one more question about parameters. How do you analyze other parameters? So you notice that when we were doing a study, it basically brought up a separate window and then asked you to choose which parameters you physically want. And we obviously described that we've got the latest parameter set. These are all the different standards that are available through the software. And then on the right hand side, for example, if I choose the latest standard, if I click on here, I've got primary, roughness, waviness, bandpass. So you have access to all the parameters and different standards and different parts of the software where you're looking for primary, roughness, waviness, and so forth. Okay, so I think that's answered all of the questions that have been sent through, and I hope you found this useful. Please look out, like we've said, for any future invites for webinars. This was just a very general kind of overview of the complete software package. Future webinars will start to kind of home in on specific aspects of the software. For example, we're looking at the analysis tool here. We may very well start to look at how we interact with that specifically, and getting into desktop publishing and bringing in images and other things that are associated with the analysis side. Programming, for example, would be another future webinar which will go into how we use variables and things like that. So please keep an eye out for those, and I hope this has been useful. Thank you very much.